4-2 dividing monomials. When we divide monomials, sometimes we're going to have just fractions, sometimes we're going to have those fractions that include variables. When we start off here, we're looking at just the fractions, and we're seeing what we can divide both the numerator and the denominator by in order to simplify. So if we look at example 1a, we have 15 over 21. These are both divisible by 3, so we can divide each by 3 to give us 5 over 7. And that is simplified fully, so that would be our answer. For example B, we have 35 over 90. Well, both of those are divisible by 5, so we can divide both of them by 5. 5 goes into 35 7 times, and 5 goes into 90 18 times. So again, that is simplified fully, so that's our answer. For C, we have 27 over 243. Well, neither 27 or 343 have a common factor there, so we can keep it the 27 over 343. If we look at D, we have 54 over 108. Well, we can take this both and divide them by 2, and then divide them by 2 again, and again, and again, and again. However, 54 does go into 108 evenly, so we can divide each of them by 54, and when we do, we get 1/2. For example 2, we're dealing with the same thing, but now we're introducing those variables here. For A, we have 35 over 42. Both of them are divisible by 7, so we can divide each by 7. Oops. This is going to give us 5 over 6. For B, we have negative 4xy over 10x. Our rule with variables, if we are dividing them, we are subtracting the exponents that are attached to them. This x does not have an exponent on it, it's just a 1 for both of these. So because you have an x over an x, they would cancel each other out, and the only thing you have left is that negative 4 over 10 and that y over 1. So that negative 4 over 10, we can divide both of those by 2, and we end up getting negative 2 over 5. That y stays on top with the 2, so it's negative 2y over 5. For C, we have 16x divided by 8y, or 16x over 8y. We can divide both of those by 8. The x and the y are not the same variable, so they don't cancel out. Nothing can be done with them. So this is just going to be 2x over y. For D, we have 56y over 34x. We can divide both of these by 2. Remember, the y and the x are not the same variable, so they do not cancel out. Nothing happens to them. You're going to keep both of them. So the 56 divided by 2 is 28. Keep the y. And the 34 divided by 2 is 17. Keep the x. So we have 28y over 17x. If we look at our next set of examples, we're simplifying these fractions that have our variables that are raised to powers. Again, our rule, we are subtracting those powers. So it's the same variable on the top and the bottom. We're going to keep the variable, subtract the powers. So for A, we have c to the 7th power over c to the 4th power. So we both have a c on the top and the bottom. We're going to subtract the 7 and the 4 to give us c cubed, which would be our answer. For B, we have a cubed over a to the 8th power. So again, we're going to keep the a, subtract those exponents. The 3 minus 8 is negative 5. You cannot keep a negative exponent. So in order to turn that exponent to be positive, you have to bring it into a fraction and take the reciprocal of it. So it's going to be 1 over a to the 5th. So the rule is you can't keep a negative exponent. You have to take the reciprocal of the term to turn that exponent to be positive. For C, we have b to the 5th divided by b to the 5th, or b to the 5th over b to the 5th. So again, we have the same variable, top and bottom. We can subtract those exponents. This is going to be b to the power of 0. Any number or any term, variable, anything raised to the power of 0 is 1. So this turns into a 1. For D, we have x to the 9th power over x to the 11th power. We keep the x, subtract the 9 and the 11. We're going to get x to the power of negative 2. Remember, you can't keep the negative 2. You have to turn it into a positive 2. So take the reciprocal of that term. It's 1 over x squared. Our next set of examples, we have x to the 9th power over x to the 5th power. So again, we're going to keep the x, subtract the 9 and the 5. We're going to be left with x to the 4th power. For B, we have x to the 2nd power over x to the 7th power. So keep the x, subtract the 2 minus 7. That's going to give us x to the power of negative 5. Take the reciprocal to turn that negative 5 into a positive 5. We're going to have 1 over x to the 5th power. For C, we have x cubed over x cubed. So again, keep the x, subtract the 3's. Well, that's going to leave us with x to the power of 0, which is just 1. Our next part in our notes is finding the greatest common factor of two terms. So when we find the greatest common factor of these two terms, we can find all of the factors of one of the numbers and then all of the factors of the other numbers, and then keep the variable with the smaller exponent, okay? So as long as we have variables that add up or match, then we keep the one that has the smaller exponent. So if we look at example A, we have 72x cubed yz cubed and 120x squared z to the 5th power. That's 72. The factors of it are 1 and 72, 2 and 36, 3 and 24, 4 and 18. We also can do 6 times 12 and 8 times 9. The 120, it's going to be 1 and 120, 2 and 60, 3 and 40, 4 and 30. 5 goes into it 24 times. 6 goes into it 20 times. 8 goes into it 15 times. And then 10 goes in 12 times. So we want to find the greatest common factor here. The one that's the greatest is that 24. So the number that we're going to have is the 24. Then we have x cubed and x squared. We're going to keep that x squared, cancel out the x cubed because we want to keep the one that has the smaller of the two exponents. There's not a y in both, so we can't take that. Then we have a z cubed and a z to the 5th power. The z cubed is what we'll keep. So it's going to be 24x squared z cubed. For B, we have 35x to the 6th power, y to the 4th power, and 75x to the 4th power, y to the 6th power. So first, find the factors of the 35 and the 75. For the 35, we have 1 and 35, 5 and 7. For the 75, we have 1 and 75, 3 and 25, and 5 and 15. The one that's the common factor between the two, it would have been good if we wrote this correctly. This would have been a 5. Oops. Do that again. There we go. All right, so the one that is the least or the greatest common factor with all of these is the 5. So we're going to keep the 5. The smallest of the x is the x to the 4th, and the smallest of the y's is the y to the 4th. So that x to the 6th and that y to the 6th would cancel out pretty much, and we're going to keep the y to the 4th and the x to the 4th. So this is going to just be 5x to the 4th, y to the 4th. For our next set of examples, we are simplifying with a little bit of some bigger numbers and bigger powers. So we have, for A, 35x to the 3rd power, yz to the 6th power, over 56x to the 5th power, yz. We're going to divide both the 35 and the 56 by 7. This 35 is going to become a 5. This 56 becomes an 8. So from here, that 5 is going to stay on top, the 8 is going to stay on the bottom. We're going to have x to the 3rd minus the 5th y to the first minus the first, and z to the sixth minus the first. So from here, subtract those exponents, keep whatever you need on the top, whatever on the bottom. That y to the first power minus the first power is going to cancel itself out, right? Because those variables are the same, so they cancel out. We're going to keep the 5/8. It's going to become x to the negative 2. Y to the first minus the first is y to the 0, which is just 1, so it cancels out. And then that z is z to the 5th power. So because we have that negative 2, it goes on the bottom of the fraction. So we're going to have 5, the y cancels out, z to the 5th over 8x squared. For b, we have 64x cubed y squared over 88xz. So we're going to divide both of these by 8. The 64 becomes an 8, the 88 becomes an 11. So this is going to be 8 over 11 times x to the third minus the first. The y squared doesn't have another y, so it's going to stay. And that z is going to stay on the bottom as well. So we're going to give it a negative 1 to remember, or to remind ourselves it goes on the bottom. So the 3 minus 1 is 2, so it's going to be x squared, y squared, and z to the negative 1. So from here, we're going to keep the x squared and the y squared on top, so it's going to be 8x squared, y squared, and then the z goes on the bottom, so it's going to be 11z on the bottom. 8x squared, y squared over 11z. For c, we have 27xy to the 5th power, z to the 7th power, all over 18x to the 4th power, y to the 2nd power, z to the 9th power. So we're going to divide top and bottom numbers by 9. The 27 turns into a 3, the 18 turns into a 2. So we're going to have 3 over 2, then x to the 1st minus the 4th, y to the 5th minus the 2nd, z to the 7th minus the 9th. Remember, anything that's a negative exponent is going to go on the bottom of that fraction. Take the reciprocal of the term. So the 3 over 2 stays. We're going to have x to the negative 3, y to the negative 3, z to the negative 2nd. So all of these exponents with their variables have to go on the bottom of the fraction. So we're going to have the 3 on the top. Then we're going to have 2x cubed, y cubed, z squared. So 3 over x cubed, 2x cubed, y cubed, z squared.